A revolutionary leap in quantum computing might be closer than we think, thanks to the unexpected ally of 3D printing technology. But here's where it gets controversial. Could this mean the democratization of quantum computing, or will it simply reinforce the dominance of tech giants? Quantum computers, the superpowered siblings of classical computers, have long held the promise of solving problems that would take classical computers eons to crack. However, scaling up these quantum beasts has proven to be a significant hurdle. Now a team led by Hartmut Hefner from the University of California, Berkeley, has devised a novel approach that could pave the way for larger, more powerful quantum machines. Their secret weapon? 3D printing. To fully harness the potential of quantum computing, we need to increase the number of qubits, the fundamental units of quantum information. One type of quantum computer uses ions as qubits, and a crucial component in these systems is known as the ion trap. These traps hold ions in place and manipulate their quantum states using electromagnetic fields, allowing for the execution of complex calculations. And this is the part most people miss. Until now, crafting these ion traps has been a painstaking process, often limiting the size and efficiency of quantum computers. Hefner and his colleagues have developed a 3D printing technique for creating miniaturized ion traps, which could revolutionize the construction of quantum computers. Their 3D printed traps, measuring just a few hundred microns across, outperform traditional designs in both efficiency and speed. According to Hefner, you can scale to an order of magnitude more qubits, and you can speed up things. This breakthrough could potentially lead to quantum computers with significantly higher processing power. But why is 3D printing the key to unlocking this potential? Xiaoxing Xia, a team member from Lawrence Livermore National Laboratory, explains that 3D printing offers unparalleled flexibility in creating small, intricate structures without the constraints faced by chip manufacturing techniques. This freedom allows for the creation of more innovative and novel designs, opening up new possibilities in the field of quantum computing. As Shuqi Xu, another team member from UC Berkeley, puts it, 3D printing lets you reimagine things to a large degree. Ulrich Poschinger, a researcher at Johannes Gutenberg University Mainz, sees the potential of 3D printing in overcoming the current challenges faced in ion trap fabrication. He believes that the 3D printing scheme could eventually address issues such as complexity, low yield, high costs, and poor reproducibility, all of which are critical for achieving scalable quantum computing with trapped ions. The team's next goal is to integrate optical components such as miniaturized lasers into their 3D printed designs, further enhancing the capabilities of quantum computers. Hefner envisions that their tiny traps could also find applications in redesigning mass spectrometers, widely used instruments in chemistry and other scientific fields. So, what do you think about the role of 3D printing in the future of quantum computing? Is it the key to unlocking its full potential, or just another hype in the tech world? Share your thoughts in the comments below.